So we finished the last video with the question of which kind of reasoning we would expect in the domain of science and in the domain of mathematics, noting that those are different domains. Well, hopefully, a little reflection will have suggested to you that in mathematics, deductive reasoning, the kind that moves with certainty from certain premises to certain truths, deductive reasoning is quite at home in mathematics. It's almost how mathematics works. Whereas in science, because science is supposed to be about something, about the world, about real stuff, we can never achieve that kind of certainty in science. Science must start with observation. We have to observe something in the world. And while science does use mathematics, it uses mathematics a whole lot. It uses mathematics to model reality and ensure that the model behaves in a certain way. Science is always stuck with this business of a slight bit of uncertainty. So people like to use the word prove very loosely. We say the scientists have proven that viruses cause colds, for example. If we're being careful in our language, proof is never found in science. Proof is only found in mathematics. This leads to a great deal of confusion in popular discourse. Science is not in the business of proving things. If you're a scientist, then no matter what conclusions you have reached, they can always be overthrown. New evidence may come to light. Proof, in its strict sense, means establishing a necessary truth, and that's only possible in mathematics. It's even a complicated question in mathematics, but anyway. So when people start saying the scientists have proven this, that, or the other, there's no point in correcting their language. That's only going to pick a fight. But what you should know is that this is already a political discussion, that the way science is being used here is not in a disinterested fashion, but it's being used to assert an authority, and that makes the matter political. So, we're going to look first at inductive reasoning. Remember this business of figuring stuff out from the past. So you have a lot of experience, and you know this kind of thing, that if the sky is getting very dark and cloudy, it's probably going to rain. I suspect an animal might know that too. But here, if we lay it out like this explicitly, it makes it clear that we're drawing on the past to make a prediction of the future. It seems like an odd way to describe our knowledge of the world. So we could describe, for example, our knowledge of our own body in this way. If I don't eat something, I will get hungry. I have lots of experience of this. I've often not eaten something and then got hungry. So I predict that if I don't eat something, I will get hungry. We could talk that way. It seems a little odd to describe yourself in that way, though, doesn't it? Is that the only or best way to characterize your knowledge of the relationship between food and hunger? Well, if reason is your only faculty, you're sort of stuck in this corner. Inductive reasoning may form the basis of prayers of supplication. If I pray to whoever your favorite God is, my prayers will be answered because they have been in the past. Now, I think you know or suspect that prayers to one's favorite God are often not answered, especially if they're of the kind, dear God, give me a new bicycle for Christmas, right? And yet we find this kind of implicit belief lurking. And that should alert us to something, which is we stand in the present making predictions about the future. If we're making a prediction, we have a hypothesis. We say, maybe it'll be this way or maybe it'll be that way. And then we go looking for evidence. And in an ideal world, maybe we would make our hypothesis explicit, and we would look for evidence, and the evidence would either falsify our hypothesis, showing that it's not the case, or it would confirm or support it at least. It would be in line with our hypothesis. Now, again, this is a very abstract view of how one might characterize thinking, and this is a really poor model for what people actually do. Most of the time, in most situations, once we're not reasoning formally, but we're just going about our lives, thinking about stuff and making predictions about stuff, most of the time, evidence that supports our pre-existing beliefs is warmly welcomed, acknowledged, and noticed. Problematic cases that might falsify it, those times you prayed to your favorite God and didn't get the bicycle for Christmas, are easily forgotten if the deity has provided some positive examples in the past. This is known as confirmation bias. It's the rather informal idea that we're not neutral observers of the world. We couldn't be neutral observers of the world. And our reasoning, even though we may think we're reasoning in a purely logical fashion, is always going to be biased by our pre-existing beliefs. And there's no unbiased state. We can make ourselves aware of this, however. Now, some people are called upon to give unbiased advice. Scientists, for example, or officers of the law, to whom the law is supposed to apply equally to everybody. And when we all come up before the judge in court, it's supposed to be a theatre of fairness. And we all know that's not probably an accurate description as well. And some people turn to people like religious leaders for clear and certain advice. So confirmation bias can be a real problem. And one way of thinking about this is as the origin of stereotypes. So stereotypical thinking means imposing your pre-existing expectations onto someone who knows nothing of them. So this advertisement, for example, takes advantage of the fact that most people expect nurses to be women. And so it's playing with that when it says, are you man enough to be a nurse? So there's not an easy way out of this because, as I said, nobody reasons from a position of godlike knowledge and disinterest. But we can make ourselves aware, perhaps, of our biases. You may remember we looked at the superstitious pigeons of Skinner. And one way of interpreting them was to treat them as if they were creatures of reason, as if they were moving their head around or twirling around in the cage because these actions looked like they were going to generate food. You remember the pigeon doesn't know when the food's going to arrive, and the pigeon is very, very hungry. So every time the food arrives, it's a bit like the gambler in Las Vegas hitting jackpot. And so the bird does stuff and keeps repeating it. And of course, it's not efficacious. There's no link between the bird behavior and the arrival of the food. But every so often, food's going to arrive and the bird's going to say, just like the gambler in Vegas, ha ha, my system works. And we could argue that way. We could also argue that that's a poor way of understanding pigeons, because they're not actually human gamblers in Las Vegas making cold calculating decisions. I'll leave it up to you. So we can describe the same situation in many ways. So when we're talking about these kinds of biases in our reasoning, there's some really interesting work which is quite popular. It's informal. I wouldn't take it as terribly rigid or formal. It comes from Daniel Kahneman, who has spent a lot of time modeling how people make economic decisions. I've listed there a few biases Kahneman has, and which confirmation bias there is number 7. But there's lots of other biases that, blind spots and sticking your head in the sand, so refusing to accept things, or the ostrich effect, and so on. I'm not going to list them all. There's an awful lot of them. But listing these kinds of biases in our thinking can be a useful way of making ourselves aware that we're fallible and that we will remain fallible, but we can sometimes spot our weaknesses, and we can be, in this way, maybe be less inclined to impose our certain views on others. Maybe. We'll see.